assuming somebody's working. Alright. Let's be straight. So this was VA, VB, and VAB.
Yeah.
And what will we get?
So the magnitude of VAB is 6.72 meters per second. And then the angle from like between the coordinate and VA is 22.5 degrees.
That one right there?
No, the one below it.
That one right there. Okay.
And then the one above
Sorry,
it
what was
is
the number again?
22.5 degrees.
One more time.
22.5 degrees.
Okay.
And then the one above it, the one that you first did, was 26.5 degrees. And then the one from VB to VAB, so the top one.
That angle?
No, the one on the top one.
That angle right there.
23.0 degrees. Yeah.
Then we're supposed to find the magnitude of VA and VB?
Mm-hmm.
All right. Well, we know we can easily get the polar form of VAB from this, because we know the magnitude, and all the numbers, all of the magnitudes will be in meters per second. So VAB is 6.72 at an angle of, well, it's the full angle right there.
Yeah.
So 49 degrees. To put that into rectangular form, given the classic I hat to the right, J hat on, would be 6.72 cosine of 49 degrees, I hat, plus 6.72 sine of 49 degrees, J hat. Whatever that is.
Yeah.
So I now know how far over we've gone completely and how far up we've gone completely.
Yeah.
This angle right here, VA, so VA is some magnitude we're trying to find at an angle of 22.5 degrees.
Yeah.
So in rectangular form, it would be whatever the magnitude of VA is, times the cosine of 22.5 degrees, I hat, plus VA sine of 22.5 degrees, J hat. And then VB, we need to figure out some angle here. I know this angle here, 49 degrees. I know that is a right triangle because I made it a right triangle.
Yeah.
So I can figure out what that angle is. So if that's 49 degrees, this has to be 41 degrees, which means this angle right here would be the difference between 41 and 23, or 18 degrees. Are you good with that? The look on your face.
No,
Look on your face.
I agree with you. It's
Okay.
just-
So if I'm looking at now my VB triangle, if that's 18 degrees, this angle right here must be,
72.
so VB is equal to some magnitude times, at 72 degrees. And we can put that in rectangular coordinates. VB cosine of 72 degrees, I hat, plus VB sine of 72 degrees, J hat. And so now I know that my I hats must add up, so this plus this equals that, and this plus this equals that.
Yeah.
Two equations, two unknowns. Because this represents, this is a number of some sort. The old reliable. Yeah. Can you smell it yet?
I have no sense of smell.
Does it say, use it in a ventilated area? Doesn't say non-toxic. Anyway, so it's gonna be that plus this equals this. And then this plus this equals that. And just solve it like an algebra problem. Did you want me to keep going?
Yeah,
Okay.
so I can tell that I know what I'm doing.
Cosine of 49 degrees. What is this?
One second.
One more time?
4.41.
4.41?
Yes.
4.41 is equal to, what's the cosine of 22.5? The 4 decimal places.
0.9239.
92389.
Technically it's 87, but I rounded to 9.
And then the cosine of 72 degrees?
0.3090.
And then for the j hat equation, what's that?
5.472.
And then sine of 22.5?
0.382.
And then sine of 72 degrees?
0.9511.
So since the I hats have to, since this is the sum of those two vectors, the I hats must add up, the j hats must add up. So the two I hat components must add up to this, the two j hat components must add to that. And so I get these two sets of equations, and then it comes down to what algebra form do you want to solve it? You can do it graphically, you can solve for a variable and plug into the other one, you can do the solve simultaneously by multiplying each equation by some number and then adding or subtracting. It depends upon your mood.
Okay.
So we keep going?
I mean, if other people want, but I understood.
Okay. Anyone want to keep going?
Yes.
Okay. I'm gonna do it by solving simultaneously. So what I'm gonna do is I'm gonna take this equation here, and I'm gonna multiply by 0.9511. I'm gonna take this equation here and multiply by negative 0.3090. What that does is it's gonna make, when I distribute, it's gonna make the coefficient of VB opposite signs, so when I add them, VB is gonna just drop away, and I'm left with one equation with one single indent. So whatever 4.41 times 0.9511 is. Equals 0.9511, 0.9239 VA plus 0.3090, 0.9511 VB. So all I did was just distribute. I guess technically it's not distributing. I multiply both sides by a distribute on the right, just multiply on the left. Over here, I get negative 0.3090 times 5.072 is equal to negative 0.3. Try that again. 3090 times 0.3825 plus negative or calculators out, ready to go? Okay.
I'm lost now. Well, I did calculate the 4.41 times 0.9511 is 4.194.
Wait, 8,
7.
8787? VA plus, I don't care. Because I'm gonna add them together, this is plus something. This is gonna be the negative of it, so I'm gonna add, it's gonna be, add up to 0. So this, 1.5-ish.
One point 567.
567, and then this.
Negative 118.
1182. VA. Plus negative question mark. So now when I add them together, on the left-hand side over there, I have, let's see, 1 carry the 1, 6 carry the 1, 7. So I get 5.761 is equal to, I subtract, I get 5067 VA. So VA would have to be 5.761 divided by, that is, yeah, divided by 0.7605.
Isn't that first number for the second equation supposed to be negative?
Say it again?
Isn't the first number for the second equation supposed to be negative?
First number for the second equation, oh, yes, that should be, so thank you, but that number's wrong. So 7, so carry the 1, 2, and then 2.627 divided by that, which is something. And then it'll be meters per second.
454.
And then to find VB is you pick one of those equations, plug this in for VA, solve for VB. Or, there are other ways of doing it. Seems like that would be the simplest, but. Other questions about this problem? Which one was that? This was chapter 3?
This was chapter 3, question 10 on the textbook problems.
Okay.
Oh, that's why I had trouble with this.
Yeah. I had another question though about chapter 3.
Yeah.
I was taking one of like the practice tests yesterday,
Right?
and for some reason I kept getting stuck on a question. Wait, sorry, let me pull it up for you. It gave a scenario about like these two people racing each other, and the second question just started confusing me. It was like, so Lou started 300 meters ahead of Sue in a car race. And then they both started at rest and both start moving at the same time. Lou took 20 seconds to get up to his cruising speed of 60 meters per second with uniform acceleration. Sue uniformly accelerated at 7 meters per second squared until she caught up to Lou, at which moment in time she cruised at a constant velocity. And then the first question was like easy, because it was just talking about what is the acceleration and you had all the points. But the second one was saying at what time did the second person, Sue, catch up to Lou? And
Right.
I didn't understand.
All right, so we've got Sue and Lou. All right.
Okay.
So Lou starts 300 meters ahead.
Yes.
All right. They end at the same place, whatever that happens to be.
Mm-hmm.
The question was what time?
At what time did Sue catch up to Lou?
Okay. All right. Initial velocity was 0 for both.
Yes.
Final velocity,
60 meters per second for Lou, and then we don't know for Sue.
all right.
And then acceleration for Sue is 7 meters per second, and then
Squared.
yes, squared. And then for Lou, you don't know it, but I figured it out. It's 3 meters per second squared. So.
All right. And then we don't know time.
Yeah.
All right. So if you calculate this, I was going for a different color just to indicate we calculated it. We go from 0 to 60
Mm-hmm.
in
20
actually.
seconds.
Sorry, we do
20 seconds.
20 seconds. So change in velocity, we're changing time. Change in velocity over change in time would give us 60 minus 0 over 20. So 3 meters per second squared. So after 20 seconds, he's now cruising. Is that right?
At 60 meters per second.
So if I look at a velocity time graph for Lou, I know he gets up to 60 meters per second. At 20 seconds, he's there, and then he maintains that.
Yes.
Sue is traveling at a consistent acceleration. So we'll go for potentially a stunning visual effect here. All right, we have fresh markers somewhere. Oh, I think this is the collection. So this is Sue. I know that if I'm given a velocity time graph, what does it tell me about displacement?
For Sue, it's constant.
Say it again.
For Sue, the displacement should be constant.
What does this constant displacement mean?
It doesn't change direction at any point.
No,
More specifically,
technically doesn't constant mean that it doesn't change at all.
right? Therefore,
Therefore, it's not constant. Well, like.
displacement's not constant,
The
but what?
displacement, this problem isn't constant is what I'm saying, but the velocity here is telling us that the displacement is increasing. I don't know. Like, it's
All right,
just.
what is displacement?
Change in
No,
position.
it's a change in position in a specific direction.
Well, that's in a specific direction is implied in changing position. What else? What's the other alternative definition for displacement
Distance from starting point.
and direction? All right, so it's where you are relative to the starting point. So if that is constant, what does that mean you are doing?
Not moving.
Right? So when you say constant displacement, you are saying it's not moving. They're both moving. All right, so given a velocity time graph, what can you know about displacement?
The slope of displacement?
Louder, please.
The slope of displacement? I don't know.
Okay,
Slope.
velocity is the slope of displacement,
Yeah.
or position. But going in the other direction. Well, let's take a look at units.
Like literally?
Uh,
Are you talking like going in another direction as in a topic change? Or do you mean one is going this way and now we're going this way?
now, as in, if I have a velocity time graph, let's just assume a constant velocity. Let's say this is 20 meters per second, and over the course of 10 seconds. What can you conclude about the displacement?
It's increasing.
Okay, how could I find the displacement given this graph?
You like take the points.
There is no displacement because there's no
Right,
slope.
sorry, Eva, you were saying?
Would you multiply the x and the y, so like.
So
20
10 times 20?
Yeah, and then that would get you, 200 meters, no? That
It would,
That would
yes.
get you the displacement,
The displacement is 200 meters.
okay.
I have a constant velocity, my acceleration is 0. I can plug into my displacement is equal to VIT plus 1/2 AT squared. So my acceleration is 0, so it just becomes 20 times 10, or 200 meters, that's my displacement. There's a hand up over there, I thought.
So mine was basically could be like draw a triangle and do it that way, like one side's 20, other side's 10, and then